Okay, so we'll look at question 11. So two friends are building a skateboard ramp. They each have a different design for the ramp. Tracy draws the following diagram, and you can see it here below for the ramp. It's made up of a triangle and a square. The angle A is marked. It's to the scale 1 is to 100. Okay, so the first question then is construct a scale diagram of this part of the design for the ramp in the grid below to the scale 1 is to 50. So here they're saying it's 1 is to 100, so this one they want it to be twice as big. So it's half in terms of the number, but that means it's twice as big. Actually, they're about to tell you that here. Each side in your diagram should be twice the length of the corresponding in Tracy's. Okay, and they've done one of them for you. So here you can see it's 2 centimeters in Tracy's diagram and it's 4 in your diagram. So let's complete the first part of it. So we're going to have to go over here 4 as well, because one part of it is a square. And then the other part, as you can see here, is 3.5. So I'm going to go over double that, which is 7. 1, 2, 3, 4, 5, 6, 7. Now, obviously, you would use a ruler for this, but I'm doing it fairly quickly here. And then we've got this part coming down, so that's angle A. And they want you to measure the size of angle A. Sorry, so that's it. That's part 1 done. Part 2, they want you to measure that, so you should do that with a protractor. I'm just going to approximate it here. So that's what they want you to measure, that angle. So angle A is equal to, no, I am going to guess it, so I'm going to say 35 degrees. Okay, it's not quite 40. If it was 40, that would cut exactly there. So it's a little bit less than that. So it's between 35 and 40. So you should measure that with a protractor. And of course, your lines will be much straighter than mine. Okay, so that's part 2. Now the next one. So this is the other design. Sinead has a different design for the ramp. Part of Sinead's design is the right angle triangle in the diagram below. One of the sides is marked B. One of the angles is marked C. So this is side B here, and the angle they're talking about is there. Okay. All right. Using the theorem of Pythagoras, work out the length of side B in Sinead's design. So they want you to calculate the length of that line there, from there to there. Okay, so we want to use Pythagoras' theorem. So the theorem, basically, I'm going to give these other lines names. So I'm going to call this X and I'm going to call this Y. So what Pythagoras' theorem says, and I'll use, so the square of the hypotenuse, which is this one, so B squared is equal to Y squared plus X squared. Okay, so that's the formula we're going to end up using. So let's start with that. So we don't have B, that's what we're trying to find. So Y squared is 180 and X squared 96. Okay, so I'll quickly do that on the calculator. So 180, so that part is 324. And this part is 9216. So adding those together, you get 4161. And of course, this is B squared. So this is still B squared. This is still B squared. So now B is the root of this number. So I need to get the square. So when I get the square root of that, the answer is going to be 204 exactly, 204 centimeters. Okay, so that's the length of side B in the triangle. Okay, so Sinead knows for the angle C that tan of C is this number, which is, so the angle C, the tan of that is equal to this over this, 96 over 180, okay? So what I need to do is get the inverse tan of this number. So you can type this directly into your calculator with the hitting shift and then your tan function, and you will get an answer of 28.07, then 2, 4, etc. So we'll round to the nearest degree, so we'll just make it 28 degrees. Okay, so that's your answer for that last part.